A key part of programming is state. Rather than start with the computer science definition of state, let's go with something that might be a little more familiar, such as the dashboard of a car. The most noticeable parts of a car's dashboard are probably its gauges and odometers. They show the car's current speed, its fuel level, distance traveled, and so on, each of which is some kind of numeric quantity. Dashboards also have warning lights, such as the low oil warning light or maintenance light. Each of these lights is either on, indicating that there's a problem that needs the driver's attention, or off. This on-off true-false information is called a Boolean value in programming. So the information on a car's dashboard, such as speed, fuel level, whether or not the car needs maintenance, taken all together is a visualization of the car's state. Keep in mind that the dashboard isn't the car's actual state. It's just a visualization of it. To see what I mean, think about what happens when the driver changes the car's state. For example, the driver presses the accelerator and the car starts to move faster. The dashboard then updates to show the new speed. So the car's state is actually how fast the car is moving, and the dashboard is just helping the driver visualize that fact. Now, internal circumstances can also change the car's state. For example, as you drive the car, it consumes fuel. The car's state is how much fuel remains either in the tank or in the battery, and the dashboard hopefully updates the fuel indicator. But what happens if the car's state and dashboard aren't in sync? For example, what if your dashboard breaks and doesn't actually show your car's speed? Well, that could be a big problem. You might get a ticket, or worse. It turns out that this type of mistake is quite common while developing an app. That is, for your user interface might not accurately represent the internal state of your app. You may have sometimes come across an app with a bug like this. For example, an app says you have 5 new messages, but when you check, you actually don't have any at all. One of the nice things about Flutter is that you develop your apps in such a way that your user interface and your state are always consistent, which prevents these frustrating types of bugs. Let's take another look at Bullseye and think about what our app state would look like if we want to track whether or not a pop-up is visible when the user taps the Hit Me button.
Open your project in progress or download the starter project for this episode. In this demo, we'll keep track of when the pop-up is visible. For this, we'll add a variable to track state. In game page state, add the following variable. We're creating a variable called alertIsVisible that can either be true or false. Remember that the underscore indicates that it's a private variable. It means it's only meant to be used by the game page state class and nothing else. The bool tells Dart that the variable is a Boolean, or a true-false value. Remember, Dart can infer the type, so you can use the var keyword.
It turns out that when it comes to displaying a pop-up alert, there are 2 possible conditions. Either the pop-up alert is on the screen, or it isn't. When the app first starts, the pop-up alert isn't visible, so the state variable alertIsVisible is false. What we want to happen is that when the user taps the Hit Me button, we'll change the state to reflect the fact that the alert is now visible and also write a method to show the alert.
Now to update the alertIsVisible variable in the onPress property of the text button, add the following. Since we aren't using the printHello method, feel free to delete it. Now to write the showAlert button. First, we'll define a private method that takes in a context. A context represents the current widget in the widget tree, and we can use it to access parent widgets or find out about the screen location information. Now we'll create a new button to dismiss the pop-up. The navigator pop method does the actual dismissing, using the context, and then sets the alert is visible property to false. Notice the print statement. The $sign allows you to put your variables in text known as strings. Now call the show dialog method. This takes in a context and also provides a builder. In the builder, we return an alert dialog widget that has a title, a content, and we provide some actions. The elevation is the Z position of the dialog, that is how close or far away the dialog is from its parent. Now update the text button to call show alert. This now shows the alert dialog. Granted, there's been a lot of code, and some of it seems really complex at the moment, but soon you'll be able to write this on your own. It just takes time and practice. Now build and run. Tap the button, and look at that. You have a dialog. Nice work.